In this third video, we're going to continue defining trig functions, this time tangent. We're going to still let P represent an ordered pair xy on the unit circle. It'll be associated with an angle theta in radians. X and y will have this relationship because we're on the unit circle. But tangent applied to theta will give us a different output, identically y over x. And as before, we're going to fill out this input-output chart just to see how to evaluate tangent for common values of theta. And we'll turn to our unit circle. And we'll start with an angle at 0, find our ordered pair, and put the y value 0 over x value 1. 0 over 1, or 0. So if theta is 0, tangent of theta is also 0. But if theta is pi over 6, we rotate up to pi over 6, find this ordered pair. Tangent of theta is y over x, 1/2 over square root 3 over 2. The denominators cancel, and we're left with 1 over radical 3. Now that's not always how you see it in the back of the book. Usually that'll be rationalized. Let's see if I can squeeze that in there. They'll multiply the top by radical 3 and the bottom to get square root 3 over 3. When our angle is pi over 4, y over x is this ratio over itself, and you'll notice y over x will simplify to 1. We rotate up to pi over 3. When theta is pi over 3, we'll get square root 3 over 2 over 1/2. The denominators will cancel, and y over x becomes square root 3 over 1, or just square root 3. Now at the North Pole, when we rotate up to pi over 2, y over x would be written down as 1 over 0, but we know that's an undefined ratio. Okay, so in the first quadrant, looking down here, tangent of 0 is 0, tangent of pi over 6 is square root 3 over 3, tangent of pi over 4 is 1, and tangent of pi over 3 is square root 3. Tangent of pi over 2 is undefined, and as we continue on into the second quadrant, since quadrant 2 is the negative positive quadrant, y over x is going to be a negative ratio. Okay, so let's continue around. Tangent of 2 pi over 3 will be square root 3 over 2 over negative 1/2. The denominators cancel, and we're left with square root 3 over 1, negative. When the angle is 3 pi over 4, y over x will reduce to negative 1. And when theta is 5 pi over 6, y over x, the denominators cancel, and we're left with 1 over negative square root 3. Again, in the back of the textbook, that'll be rationalized. And if I can squeeze that in, you'll normally see tangent of 5 pi over 6 written this way. Now tangent of pi would be 0 over negative 1, or 0, which is defined. We'll drop down to the negative, or the bottom half. First, in the third quadrant, we'll have the negative quadrant, so y over x will be positive, and then we'll turn to the fourth quadrant, the positive negative quadrant. Okay, so let's quickly do this. Tangent of pi was 0 over 1. Tangent of 7 pi over 6, negative over negative. The denominators cancel. We're left with 1 over radical 3, and we know we can rewrite that. For 5 pi over 4, we're at that bisector. Y over x is a ratio over itself, and that'll reduce. 4 pi over 3, we get y over x. The denominators cancel, we get positive radical 3. When the angle is 3 pi over 2, the denominator would have been 0. Y over x would be undefined. And then we work our way back up until at 2 pi we get 0 over 1. So at 5 pi over 3, after cancellation, tangent is negative square root 3. At the bisector, tangent is negative 1. And at 11 pi over 6, we get that unrationalized ratio, which can be simplified. Okay. You might want to get your technology out and find the tangent button and plug in common angles like pi over 6 and see what decimal you get for the output and make sure that it matches the decimal you would get for square root 3 over 3, and so on. Good luck with that.